Alrighty, so here's my membrane concept map. So I started with plasma membranes, and it's a huge bubble because that's the biggest definition, and everything, all of our definitions could fit into it. So I started with that one and let everything kind of stem off of it. So over here I have detergent molecules, and they're kind of off to the side on their own because they break down the plasma membrane and nothing else really goes with that, kind of. So they're off by themselves. And then vesicles is by itself too, as well. Wait for it to focus. And peripheral membrane protein, because it's a part of the membrane. And then integral membrane protein is also, off to the side. It doesn't really have anything stemming off of them, but they are a part of the plasma membrane, so I have them stemming off of them because they're like the biggest. Yeah. And then you have glycoproteins, which goes to the protein attached membrane associated protein. And then you have the glycolipids. And then off them you have unsaturated fatty acids and saturated fatty acids. And then also the lipid-linked membrane associated proteins, which I kind of had to really squeeze that one in there, so it's kind of small, sorry. And then back to the plasma membrane, there's membrane associated proteins. And that also goes back to the phospholipid bilayer, which is also on the plasma membranes, but I have the two models, the fluid mosaic model and the sandwich model, because they're both models of the phospholipid bilayer. And then the hydrophobic tail of the phospholipid. And then I have the anchor membrane proteins. And also the amphipathic molecules. And that's also attached to the hydrophilic head of the phospholipid. Which also goes back to the phospholipid bilayer. And then off of that I have enzyme membrane proteins. And then off of the phospholipid bilayer, the last one that I have is membrane channels, and that's another big one. Because the channels are so important. The membrane is there to protect the cell, and so you have to have the different channels all throughout that allow all the different things to come in and out, and you have to be really careful with that because, it is a living thing. So you have the ion channels, and then there's also the gated ion channels, and they all have selective permeability, pretty much. They select what comes in and what goes out, just trying to keep everything safe, basically. And then you have the electrochemical gradient coming off of the membrane channels, which goes to the concentration gradient, and off the concentration gradient you have the isotonic solutions and the hypotonic solutions and the hypertonic solutions, and also active transport and passive transport, and simple diffusion. And off of the passive transport I have osmosis, which is another big one, and also channel mediated passive transport, which goes back to membrane channels. And membrane channels also has the ion channels, so there's also that one. Yes, and off the electrochemical gradient there's transporter membrane proteins, and protein attached membrane associated proteins, which goes back to glycoproteins also. Sorry about the stuff. But the transporter membrane proteins goes to the receptor membrane proteins, because I have those together because the membrane proteins that are being transported are usually going to a certain receptor, kind of. So, and that's my concept map.